Hello, today we're going to be working with a worked problem on point vectors, point forces. This particular point force, it's in 3 dimensions, so we've got x, y, and z components possible. And we're asked to convert this vector from a magnitude and direction form into component form. So with component form in 3D, we're going to have to kind of do this in 2 steps. So the first thing we're going to look at is we always are going to draw a triangle with our diagrams, and so this triangle kind of in red that's also being used to denote the angles is my first part. So first, it's good when working with these 3D vectors to kind of think about the shape. So I've got my x, my y, and my z directions. What this vector is I've gone out 30 degrees from the one direction like so, and then I'm going up by 45 degrees. So if you think about that, it's kind of sticking out into space like this. So with that, I've got my first triangle. I'm going to do the 45-degree angle going up from the xz plane into y. So I've got a triangle kind of like this. And I know that this is my 30-degree magnitude over here. This is my 45-degree angle over here, and it doesn't look like it because of the perspective, but this is my right angle right here. So I've got a triangle like this, and I know that one of these is going to be, so this is the overall magnitude of 30 newtons. This is going to be the force in the y direction, and then on this side actually it's neither in the x or the z. This is the magnitude of the force in the xz plane. So I'm going to call this one fxz. Alright, so we've got a pretty simple setup. We can kind of deal with this as a 2D shape now. So fy is just going to be equal to, since it's the opposite side, it's going to be 30 times the sine of 45. Which ends up being equal to 21.2 newtons. And then my fxz, which is kind of an intermediate step, is going to be 30 times the cosine of 45, which is also 21.2 newtons. Alright, so now I've got a second triangle I'm going to draw in. So my second triangle, if I go back over to my diagram, it's going to be entirely in the xz plane. It's going to look like this. So I've got, this is fxz, it's the same line I have up here, and I've got a part that goes in the x direction and a part that goes in the z direction. So this is my right angle over here. And if they know that this is 30 degrees, and that's this angle right here. So with this, I know fxz. I figured that out right here. That's the hypotenuse of my triangle. This over here is in the x direction. This is fx. And right here, this part is in the z direction. So this is fz. All right, so fxz, fx, and fz are the 3 sides of my triangle. So fx is going to be equal to the hypotenuse, which is 30 cosine 40, or sorry, 30 cosine 45, and it's the opposite side, or sorry, fx is the adjacent side, so that's going to be the hypotenuse times the cosine of 30, so times the cosine of 30. And that ends up being equal to about 18.4 newtons. And Fz is again equal to the magnitude of the hypotenuse. So Fxz is 30 cosine of 45. And this time Fc is the opposite side, so it's going to be times the sine of 30. And And so this ends up being equal to approximately 10.6 newtons. Alright, so I've got my three components. This is x, this up here is y, this down here is z. So I can redraw my problem and write this whole thing in component form. So now I just need to draw out my axes again. X goes this way, y is going up, and z is kind of coming out of the board towards you. I draw in my force vector, and I simply need to write this out as a vector. So F is going to be equal to, here's the square brackets for the vector. X component goes first, that is 18.4. Y component is next, that's 21.2. And then finally, Z component is 10.6. Square the end of the square bracket, and I give my units, which is newtons. So with that, I've taken my original vector, which was a magnitude and direction. I really needed two angles to describe my direction. And I've turned that into a diagram, and I've got X, Y, and Z components. So with that, we're done with our problem. Thank you for watching, and I hope to see you again.